Okay, so following along. Yesterday we discovered that 1 over 125 could be written as 1 over 5 cubed, agreed? Which we put it in our calculator and we discovered it's the same number as 5 to the negative 3. So we have this little relationship between a fraction and a negative exponent. So we had a bunch of work here, blah, blah, blah. And I told you here at the bottom that a negative exponent is the same value as flipping over or moving down the base downstairs. So this 4 right here, it's 4 over 1. We move the 4 downstairs. We drop the negative exponent, but we leave everything else the same. So it still has a 3. It's still a 4. It's just in the basement. Remember doing that? Yeah, do you want me to prove to you that's real? That's true? You could type in 1 over 64 on your calculator. Okay, I'm over here, girls. You need to move the front row. Okay, what is 1 over 64?
0.05156.
Okay, could someone also type into me the calculator 4 to the power of negative 3? And tell me if you get the same thing.
It is.
All right, it is. So we're good. So then we just confirmed that what about if it was on the bottom already? What if I have a 4 to negative 3 on the bottom? Well, no big deal. That just means move it up to the top. The exponent becomes positive, but it still stays there. Still 4 to the 3. Okay? So then we decided all this stuff. We did a bunch of work. So let's come down here to class example number 2. I'll erase this. And we want to know, is 8 to the 3 divided by 8 to the negative 1 actually the same as 8 to the 4? And there's lots of ways to do this. You could just, hey, wait, the bases are the same and we're dividing. So what do? Keep the base and subtract the exponents. Now when you do this, watch. You have to go 3 minus a minus 1. Ooh, you can see a place where we might make a mistake there, right? Which becomes, of course, 3 plus 1, which is 8 to the 4.
Wait, how is that a plus?
I just explained. Because we know if the bases are the same and you're dividing, you keep the base and you subtract the exponents. 3 minus a negative 1 becomes a plus.
Oh, wow.
Now, the other way to do this is maybe quicker, I don't know. You also know, you just learned yesterday and today, that this guy with a negative exponent, if you put the negative exponent on the bottom, put him on the top. So he comes up here, he's just 8 to the 1. Now, timesing, keep the base, add the exponents, 8 to the 4. This is true. Okay, do you think this is true or false?
Yes, because the bases aren't the same.
The bases are not the same. So do you think we just divide the 8 and the 4 and then subtract the exponents? No. Mm-mm. False. No. What are the rules about? If the bases are the same, right? You can't do stuff in the bases. All you could do is you would have to actually type it in your calculator and see if you got them to work. 8 to the 3 is 8 times 8 times 8, which is 64 times 8. I don't know what that is. And you could divide that by 1/4, but you aren't going to get 2 to the 4th, trust me. Okay, is this letter C true?
Yeah.
A to the negative 3 is the same as 1 over a cubed. Yeah, it is. How about D?
Yep.
I have some yeses. All in favor say aye.
Aye.
Any opposed say nay. You're all wrong. That is not true.
Give me a straight.
This is not true. Figure out, why is it not true? You got it wrong. Why is it not right?
Is it the 9?
What about the 9?
It's just the only thing different than the last question.
The 9 is, yeah, it's not incorrect. So
Oh.
It should be 9 times 1 over 8.
Jeffrey thinks it should be this. Is he right? Tell us again, Jeffrey. You are right. Why do you think that?
Because there's no parentheses.
Because there's no parentheses. He's saying if it was like this, now it all goes downstairs. but there aren't parentheses. So to what does the -3 apply? Only to the A. See it?
Yeah.
The A has a negative exponent, but the 9 does not, actually. So the 9 stays in the A cubed. So watch out for those little tricks. They're going to catch you. Okay, simplify and write the answer with positive exponents. We can simplify like we've always done first. Two bases being multiplied, the bases are the same. What do you do to the exponents?
-7.
Add them together. A to the -7. Right on. But now, we simplify, check. Next point is to write with positive exponents. So what is that the same as?
1/87.
Truly. Okay, do that. Good. Well, because a negative exponent on the top, you can move it downstairs
Yeah.
and give it a positive exponent. Don't forget, if you put it downstairs, you have to put a 1 on top to show that there's somebody living upstairs. Okay. All right. B. Anybody want to take a 6x squared divided by 2x to the 7? Anybody want to take a roll with that? Yes?
Okay, so it's division. So
Yeah.
you take away 2 from 7.
Okay, so I have x.
But what do you do once the bases aren't the same though?
Bases is
Are the bases the same?
Yeah.
What is the base?
X.
X. What is not the same?
Oh,
The 6 and the 2. We don't care about the 6. Just go divide 6 and 2 like you've always divided 6 and 2. 6 divided by 2 is what?
3.
3. That's not new to our game. We've been doing that game for a long time.
So just be 3x5, right?
So then, almost.
Wouldn't it be negative?
But don't you take 2 and you subtract 7, so it is -5. Okay? But you're all smarter now than you were a minute ago. So we can now write this as a positive exponent. Help me out. Go. 3 over.
X to the power.
You see, you just learned that. Just moments ago, you learned that the negative exponent only applies to the x. So only move the x. Leave the 3 where it was. Well done. Okay, now we just got to do it enough times it sticks. All right, how about C? What could we do?
Can you
Flip
just-
something? The 2 is on the bottom. Should the 2 move at all?
No.
Are there any exponents applying to the 2? No, it needs to stay. So the 2 is going to be down there. It doesn't move. What else could we do?
Oh,
What do you think?
Wait, do you do 6 take away -5?
Yeah.
How do you do that?
It's a minus minus, so that becomes
Positive.
a positive. So it should be y to the 11 on the top. Here's another way. So this negative exponent guy, move him up here. There you go. Isn't it the same thing? Because y6, y5 is y to the 11. Good. Okay. Ready? We're going to get a little more complicated. That's what you were hoping for.
Yeah.
Joey, are you following along now? You writing these in your book? You're going to have to write them down so you can look back to the examples when you're home. You don't know what to do. You're going to look back and say, how did we do that one? Okay. All right. Letter D. What is the base? What is the base?
-2x.
Negative
brackets.
2x because there are brackets. So this negative applies to the entire base. So I'm going to go 1 over -2x, copy, 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 put the 3 up there. Just copy it all. Just move the thing downstairs, whatever that stuff is. Put it downstairs. Put a 1 over top. Yeah? Now you need to finish.
How do you know when to put it downstairs?
Whenever there's a negative exponent that applies to the entire base. Whatever the negative exponent applies to, move that stuff downstairs. Okay, so if I wanted to finish this, could I cube all of this? What would you get?
-8x.
X.
Cube.
All right, now on the next one, 8 over 4, and I got some A stuff and some B stuff. Can I just do the 8 over 4 part first? Let's just do the numbers like we've always done numbers. Do what you know to do. 8 over 4 is the same thing as, say it again.
2.
2, thank you. So we're going to write a 2 down. Okay, we have a fraction. What are the bases the same? No, you can't do anything with, you can't put them together at all. All we can do is make it look better. Put the a to the -5 downstairs so it becomes positive. and b to the negative 3 upstairs, so it becomes positive. So the things that have the negative exponents move to the other floor, and they're positive.
That's it?
That's all you can do. Okay. Got a little work to do on this one. 5q4 is on the bottom and it has no negative exponents. It will stay. It does not change. Only change what needs to be changed.
Oh,
What does need to be changed?
don't you have to put the 5p because it's like in brackets, right?
Yes.
And then you gotta do, but you gotta put 5p like in its own basement. Right?
Yep. I like it. Put it in its own basement. Put it in the parentheses, and we need to include the 2 with it. We haven't dealt with that yet. Put a big 1 over it. So we just take the stuff that has a negative exponent and we put it downstairs. Now we have some work. What can we do? We can actually square that 5, correct. So we'll copy that down. 5 squared is 25, p squared, and then 5q4.
Negative 25.
Why would it be negative?
Because it's in negative square root of 2.
But a negative exponent does not make, it's not the same as the sign in front. That's a good reminder though. Jace, a negative in the front is totally different than a negative exponent. The negative exponent does not make it negative as in the place it is in the number line. A negative exponent flips it from the top to the bottom or the bottom to the top. Okay, good reminder. All right, so what are we at here? Gotta finish one more step. 525 would be 125. P squared Q4. Can I put the P squared and the Q4 together? Nope, they don't have the same base. Can't do anything with them. Okay. What?
I don't get the square. Why would you keep the square if you're already squared?
I had to square the 5, and I had to square the P.
Well, that's because there were 2 5s.
Nope, this was totally different. The 125 comes from here and here. But this is its own deal. This had to go downstairs, and then you have to square both the 5 and P. Okay, next. Woo-hoo-hoo. We are getting complicated.
Oh no.
That's super dense.
All right,
Oh,
it's all right. Don't panic.
oh.
Baby, don't panic. Who's a country music fan?
Yeah.
We have any? All right, we know how to make panic. We're good. All right, so what do we do here?
Country K-pop?
It's out there somewhere.
Okay, 5. What should we? Can we just change? Okay, here's what I think. Can we just change the first little thing that we see? Let's just fool around with that, right? Take this, Victor. Take this. Just adjust what we can. If it's not a negative exponent, don't change it. But if it is, let's move it downstairs. Make sure your Z looks like a Z and not a 2. I keep saying this. Make sure you can read your own writing. Had a student in grade 12 raise your hand. I don't know what I did wrong. I said, well, your 16 looks like a 4. Just the way she happened to do it. I don't know how it worked, but anyway, it was like
16 looks like a.
I don't remember what it was, something like that. Or I know she had like this, and then the next step she put 14.
Oh.
Because she thought this was a, you know what I mean? You can see how it happened. So she confused a 14 with a bracket. So once again, a whole question wrong because 14 is not. Okay. Make sure you can help. Now, let's go on. Let's go on. What do you want to change next? Does anybody know what to do? The next thing I see if I go in order from left to right is a divide sign.
No.
What do you do when you divide?
Take away the
No.
exponents.
Okay, yes. That's true.
No.
But before we do that, division of fractions, what does it mean to you? When you see 2 fractions being divided, you think about flipping and times it. It's the only time you have the option to F expletive in my school, right? No, none of this friggin' flipping, whatever, but you can say flipping X. Okay. No F expletives, except when you're in math, you can flip in times. Okay. All right. So here we go. I'm going to take the whole thing and just move it.
X5 is good.
Copy, copy, copy. Do not change anything except copy.
What?
I know. Just do it.
Just do it.
Hurry up. Break fast. I don't like a little X in between. I think that can be a bit confusing. I'm going to make that into a dot to show multiplication, okay? That is not an X. That's a dot. That's times. Okay.
No, yeah, that's
Remember-
right. We flipped it because we're timesing it now because we have two fractions.
You always flip in times. You flip the second fraction, right? Okay. We have some more work to do. The first fraction is about as simple as I can make it. I can't combine anything there. I don't have any more negative exponents, but I have a lot of stuff in my second fraction. So I'm going to go up here. This takes a lot of, okay, part of being good at math, in fact, I would say 50%. 50% of the problem with math is that kids get discouraged and they quit. They have no staying power. They don't know how to work through it. They get mad. They I don't know how to do this, and they walk away. There's no perseverance. Be perseverant. Be okay with having to write something down again, and be neat. If you can just be perseverant and neat, half the battle is won. Okay, it's true, isn't it?
Isn't it persistent, not persevering?
Perseverance is to work through the hard stuff. To persevere. You're hanging on, and you're hanging in, and you're hanging out. Okay?
It's Friday afternoon.
Persistent is the same thing. Actually, persistent would be the same thing. Persist would keep at it until you get it. Yeah, it's the same thing. Okay, I'm copying that part down right here. Copy. Hold on. The next thing I would do is move everything that has a negative exponent, move it to the other side, make it positive. So if it has a positive exponent already, I'm going to keep it where it is. But this y cubed, he's going downstairs. This z squared is positive. He has to stay. Okay. Then in the basement, what do we got going on here? There's a 15. He has a positive exponent. He stays. X to the 8 stays. Y to the 3 stays. But z to the negative 1 goes up. And when you put it up, it's got a positive on it now. Right? When you move it, the exponent is now positive.
Okay, so basically what you're telling me is we took the negative exponent letters and we swapped them.
Yes. That's all I did. Okay? Now, be perseverant. Let's go on. First thing has nothing to do, well, we can, okay, do you want to go straight across at this point? Or do you want to start canceling? Go straight across?
Straight across.
Okay, let's go straight across. Straight across. The only number I have up here is a 5. Put him down. X to the 3, X to the 5 is X to the 8. Z2, Z1 is Z to the 30. You know what I mean? Okay, next. Straight across on the bottom. The only number I have is a 15. Do I have any X's? I have X8, that's all I got. How about Y's? Y8, Y3, Y3.
14.
Y to the 14th power.
Let's go.
How about Z? Z squared, is that all I got? That's
Yep.
all I have. Okay. All right, so we're down to this quite simple thing right there. We're not done, but we're down to that. One more step and you're done. The X to the 8s become 1s. There's one on the top, one on the bottom, so they're 1. So this is done. 1.
All right.
What's 5 over 15?
That's one
over 3.
Uh-huh. And there are no other Y's, so he's going to be down there. He's down there to stay. And the Z cubed over Z squared
3
basically
minus
is,
2? Is it a
Yep.
negative 1?
it's positive 1. It's either the 1 on the top. So all of that big mess turned out to be Z over 3Y to 14. And you can actually ignore those 1s if you want to. That's it.
Wait, why do we put the Z at the top?
Because it's Z3 over Z2.
Which is Z. Oh, that's why. Because the fractions are all.
This is way too.
This is like having Z, 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 Z.
And
They cancel, leave you 1 Z on the top.
I see.
Okay. All right. Can someone, yeah, I know, perseverance. We're not even done the lesson. Okay. This is why we're glad we started the lesson yesterday. No, we can't. Why is this true? Who can tell me? I know that Jeffrey can tell me. Can the rest of you tell me why this is not true?
Boys' locker room is just so big.
What are we doing?
Okay, thank you. All
It's too hairy.
right, Abby Genesis, can you tell me why that's not true?
Oh. Third.
Abby Genesis, can you tell me why that's not true?
No, I can't.
Sydney Reed, can you tell me why it's not true? Oh, come on, think, girls.
I know some typos.
We just talked about it. Danielle, can you tell me why it's not true?
Oh yeah, because there's no brackets, right?
So what does that mean? Why? What's about brackets?
Good question.
It's about the brackets or the lack thereof.
Yes.
Sydney Reed. She's giving me a hint. Something about the brackets. Danielle said there's no brackets. Okay, we don't have time. Brooklyn.
The bracket or like the -3 only applies to like the p, so the 2 has to go on top.
The negative, write it down, especially if you didn't know what I was talking about. The -3 only applies to the p. So only the p should move. Agreed? The 2 should not be moving. The 2 should not be downstairs. Okay.
Wait, so the answer would be 1
2.
p to the
No,
third
2 over p to the 3. That's what the correct thing should be. Only the p3 goes downstairs. Got it? Abiogenesis?
Yes.
Okay. Now I have one more little tweaky thing to show you. It's not complicated. What do you suppose a negative exponent means again? Come on. What does a negative exponent do?
Flip.
Flips.
Screws it.
It flips. Tail, it flips. So this flips this. Just like that. That's it.
Oh. Whack. That's whack.
It flips the base over.
So
So guess how you do this one?
Oh.
5 over 2 to the -3. What do you think that's going to become?
2 over 5.
2 over 5 still to the what power? 3 power, which then you could find out what the answer was. That's all it does. Okay? Nothing, it's the same as it was before. Nothing new. Just making sure you get it. It's going to be a fraction. Here's the deal. A negative exponent flips the base over. I got a little arrow over and over and over again for you for a reason. Okay? A negative exponent flips the base.
What if there's no brackets on the fraction?
What if there's brackets on the fraction?
Oh, what? No brackets.
Oh, no brackets. So what if it was like this? Okay, tell me what the -3 applies
Oh,
to.
the 5.
Only to the 5.
Oh.
So you leave the 2 where it is,
And then you
and you put this downstairs. Right?
What?
I see.
Well,